Hi, I'm Sarah Tilley from Curious Maths. In this video, we're going to be looking at the formal written method of short division, but we're going to focus on regrouping and remainders. So if it's your child's first experience of short division, then I recommend you watch the other video first, which is short division without regrouping. It's the place to start. And once your child has some more experience, they'll be able to move on to this. So in England, children might get introduced to short division in year 4, although it's non-statutory, but it is statutory in year 5. So in year 5, children will be expected to divide using short division, a 4-digit number by a 1-digit number, and this will have regrouping and remainders in it. When children get into year 6, they continue to practice this short division method, using it where appropriate, and they're also taught the long division method too. So in this video, I'm going to focus on short division with regrouping and remainders, with a big focus on how we teach that understanding of what's going on behind the question and how we can use manipulatives and images to help us do that. Let's have a look at some manipulatives that you could use at home to help you with short division. And these are the kinds of things we use in school, in loads of different maths lessons, actually. So at the top, the blue ones, they're called base 10 or Deans. Deans is simply the name of the gentleman who invented them, and you may well remember them from school. They're really great because you can actually see the value. And this is 1,000. It's made up of 1,000 of these squares. We have 100 here, and you can actually count out 100. You could put the 10s on there and see that there are 10 lots of 10. We have a 10 here, clearly marked, and we have a 1. Underneath, these are called place value counters. Haven't been around too long, but they're a really great addition to the maths resources. So they're simply counters with a value written on them. And these ones are foam. I find they're particularly good because they don't make so much noise when you play games with them. But as you can see, written on them is the value. And really helpful when you're starting to look at bigger numbers, because obviously this takes up a lot more space. Now your question will be, where's my child at? Does my child need to see 100 to realise it's 100? Or would they do okay with the place value counters? There's a little bit of a developmental jump between these two. So we often use these a lot for children, perhaps, who need to visualise and see the size of the number. But by the time we get onto hard short division, we will be simply using these, and then we'll be moving to using short division without any manipulatives at all. Finally, you could use counters or cubes, something like that. So the colours don't need to match the ones that your child perhaps uses at school. They need to be flexible mathematicians, but you can just assign a colour cube to a value, write that down, and then you can use the cubes you've got. Let's have a go at this question, 452 divided by 4. And I've set this out as a short division. Now, just to note, this is a short division layout. I don't like the term bus stop. It's been around for ages, hasn't it? And you might have been taught it that way when you were in school, but there's not really any maths relevance with a bus stop. So we like to use the formal term, which is short division. So really try and use that with your child. So I've written it, and I've also built it using the place value counters. And you can do that straight away with your child. You can write the question and get them to build it. And if you don't have place value counters or cubes at home, you can draw it, and I will show it on the next one. So this, remember, is a little bit different for your child because they're starting on the left and they're used to starting on the right. But of course, if you've done lots of questions using the place value counters with short division with no regrouping, it will come quite quickly. So when we divide by 4, we're going to put it into a group of 4. So we start with 100s. We can see one group of 4. Next, the 10s. We've got 5 10s, and we need to group them into 4s. So look, we've got one group of 4, but we've got 1 10 remaining. So we can put that one group of 4 up here. But this 1 10 needs to be exchanged, and we exchange one of those 10s for 10 1s. And this takes a little bit of time, and obviously we're hoping that by committing the time to doing this, it's going to make a long-term difference. Now we can say, how many ones have we got? And your child might need to start all over again and count how many, but there are 12 ones. And look, we can see those 12 ones in our calculation. Now we've got our 12 ones and we need to put them into groups of 4. One group of 4, 2 groups of 4, and we can see 3 groups of 4. And it is useful to organize them like this in an array, because by doing that, then your child will spot if they've made a mistake. It's really quite obvious if there's going to be a remainder. So I can see 3 groups of 4. So we get your child to finish off by saying the full calculation, 452 divided by 4 equals 113. Now, what we can do next is build on that question, something that I always like to do. So we're going to actually increase the value by 4, which would make it 456 will be the next question they do. And to start off with, they may not relate them, although if you've been doing this approach when you've been teaching short division with no regrouping, it might well work. But actually, they might want to start all over again, or they might notice that it's going to be very similar to begin with, but then they're going to have an extra group of 4. So it might be that they add another group of 4 here so that they have it. It might be that they put it all back, because remember, the question does look slightly differently to begin with. We had that, didn't we? And then we want that. So they might want to build it again and start the process. But what we're trying to do is, are they noticing, and it might not happen instantly, that you're just adding 4 more each time? And you could do exactly the same. Give them the next question, which would be, how many 4s in 460? Once your child has had lots of practice of regrouping in just one column, then get them to move on to regrouping in more than one column and see how they cope with that. Use exactly the same approach. And that's really important before you bring in any final remainders. So get them secure and then build to this type of question. So I'm skipping out the bit with 2 regroups because I think you'll know what to do. And I'm moving to the one where we're going to actually have a remainder at the end of the calculation. So one thing to say that's really important is there needs to come a point where we stop using the manipulatives and the images, because actually the numbers are going to get so big and the division is going to get so complicated that they become less pointful. You just don't really see them in the same way. You can lose sight of the maths because there's just too much going on. So, this here is really at the very beginning stages to get them confident with an aim to get them to do it independently. Okay, so let's have a go. So I have done it with place value counters, I've built it and I've drawn it. So if you don't have place value counters or counters at home, this is how you could draw it. So we're starting with our 4,000s. And because I'm dividing by 3, I need to group them into 3. And I can see there, but I can also see if I'm doing a draw, I can circle it. I can see there that there is one group of 3, but look, I have 1,000 remaining, and that 1,000 cannot be put into a group of 3, and that's why we end up with this written on our short division, and we have regrouped that 1,000 into 10 tens. And I do recommend having stacks of these ready. That's what I always do, stacks of 10 ready. That's a bit of maths in itself, getting your child to put out the place value counters. Right, so now I have 13 lots of 100. You can see my 1300s, and because I'm dividing by 3, I put them into groups of 3. We'll see how many 3s we've got. Look, we've got 1 remaining. Now, we have to do the same with the draw. So to be honest, if I was in school, I'd probably build it and write it, or draw it and write it. I wouldn't necessarily build it, draw it, and write it all at the same time, because again, it's just maybe a bit too much. So this, I'm going to now model what I would do if I was doing the draw. So I would have needed to add those 10 hundreds, and your child can be counting out loud. So 100, 200, 300, 400, 500, 600, 700, 800, 900. You get a chance to say 1000 and have a conversation of how 1000 is the same as 1000. Now we can see our 13 and we need to put them into groups of 3. One group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, and look, we have 1 remaining, and we can see that with our build. And you can be saying to your child, what do we have to do with that remaining 100? Where does it go? How do we represent it in our calculation? Now, what's interesting here in this question is I haven't put any 10s in on purpose, and I put a 0 in because sometimes it throws children. But it's fine. I just need to regroup my 100 for my 10 10s. So here are my 10 10s that I've regrouped. And I need to mark that here. I can see I've got 10 10s. And if I'm doing the draw, that's when I need to draw in my 10 10s. And actually, sometimes I like to draw like an arrow and maybe cross it out to show it's gone. So I could have done the same there, used it up here. So now I need to draw my 10 10s. I'm just going to try and go for a different color just to make it stand out. 2, 30, 40, 50, 60, 70, 80, 90, 100. Right, so I have now a need to write how many groups of 100 I saw, and I saw 1, 2, 3, 4. Right, let's look at those 10 10s. I now need to group them into 3s because we're dividing by 3. So I've chosen a question that's got a lot of regrouping in it. And as I said, don't jump straight to this, to build up the regrouping. So I've got 3 groups of 3. And I have 1 10 remaining, which I'll put in now. And I exchange for my 10 1s. Here they are. So on my draw, if I was just doing a draw, it's exactly the same as before. Groups of 3, groups of 3, groups of 3, and I'm going to cross that out and exchange that for my 10 1s. Right, I'm nearly there now. I just need to put my 13 1s, and your child can count the place value counters to make sure they've got 13 if they need to. Now we need to do those 13 1s into 3s. So groups of 3, groups of 3, make another group of 3, and you start talking to your child about how many 3s in 12. So get them starting to connect their times tables. And they might say to you, well, there are 4 3s in 12 and there's 1 remaining. And that's exactly the kind of conversation you're hoping for. So we've got 4 3s are 12 and we have 1 remaining, and we write our remainder at the end. And if you're going to do the build, 3, 6, 9, 12. You can be saying that as you're modelling it. There are 4 with 1 remaining. This is the type of question your child might be asked to do if they get really confident with short division in year 5, or certainly when they get to year 6. And by the time we get to this stage, we are not using manipulatives, we're not using images. With this type of question, it would be just messy and busy. So we're just hoping that the foundation that we built with the manipulatives and the images before help them remember what they're doing and they don't actually need them. If you do find your child needs them at this stage, then I really recommend going back to smaller numbers where it makes a lot more sense to use the manipulatives and images. So this can be done either using short division or long division, and children in year 6 in England get introduced to long division in year 6. But actually, the only difference is the presentation of it. So short division, you simply write your answers above. Long division is where you start calculating as you're going along and recording the steps that you're calculating down below. And that is long division. So it's like a shorthand and a longhand version. So when we get to this kind of question, we are exceeding the times tables. You can see we've got a 2-digit number there. And so we wouldn't expect children to know their 14 times table. But what we want them to do is have confidence that they can still attack this. And again, it comes back to that kind of maths common sense idea, thinking about what I already know to help me. So when I was in school, and you no doubt, you probably went straight to a short multiplication method, and that's absolutely fine if your child is really confident with short multiplication. But let me show you the approach that I use that I find works really well. Because one of the things we always do in school when we're looking at this kind of calculation is we always draw up some facts we know. We don't start from scratch. The reason we do this is we're trying to build confidence, and we're also really trying to ease the process to make it as straightforward as possible so your child can really concentrate on the formal method. So what we do is we take the 14 and we partition it, and partitioning means we split it up. And when we can partition into loads of different ways. But on this occasion, we're going to take that 14 and we're going to partition it into tens and into the 4, like that. And that model there is called a part, whole model. And children use this from year 2. It's the same as a bar model, except it's circles, not rectangles. So what we're going to do now is think about these multiples of 14, but broken down into the tens and the ones. And this is a really efficient way, and it really helps build your child's confidence. So I've done the first couple, but I'm going to show you the next few, how we do it. So we've broken the 10 and the 4 down. So we do 5 times 10 is 50. 5 times 4 is 20. So we've broken them down, and now we're going to add them back together. 50 plus 20 is 70. 6 tens are 60, 6 fours are 24, 60 plus 24 is 84. And I'm going to stop around 7 because your child doesn't have to draw a list right up to 9 or 10 multiples. It's probably best to just go for 5, 6, 7, something like that, because then they can just get on with their question. So 7 tens are 70 and 7 fours are 28. 70 plus 28 is 98. So it's a really good way of reminding them of the 10 times table, but actually practicing mental calculation, things like that. So once we've drawn this up, we can get straight on with the division. And that's the point, really. So we're going to look at how many 14s are in 4. We know that's 4,000, and we've done lots of work using place value, and we know we're going to be putting them into groups of 14. Now, if we've got 4,000 in place value counters, we couldn't put it into a group of 14. So we put 0 above there. Next, we think about regrouping. So we put our 4 there, which is what we would have done with our place value counters. And now we're thinking about how many groups of 14 there are in 45. And these are our hundreds. So we can use this as a reference. We can see that 3 14s are 42, 4 14s are 56. That's too many. So it must be 3. So we put our digit 3 here, and we consider how many we need to regroup. So those will be the counters that were left over at the end that we had to regroup into the other column. And actually, by doing all that, this should be going quite smoothly for your child. So 3 14s are 42, 43, 44, 45. We have 3 that we need to regroup. How many 14s in 33? We can see that there are 2 14s in 33. 3 would be too many. So we put 2 14s there, and we need to put our regrouping next to the ones, just like we would have done with the place value. So we count on from 28, 29, 30, 31, 32, 33. That's the remainder of 5. How many 14s in 59? We can see that there are 4 15s in 59. That makes 56, 57, 58, 59. We have a remainder of 3. And we write it at the end of our calculation like that. Once your child has solved this question, then I would ask them a question that builds directly onto this question, rather than giving them a completely different question to do. So you could ask them a question like, if you had 4,540 and you were dividing it by 14, what would the answer be? And we're really hoping that they're going to look at what they've just done and realise that 4,540 is just one more. And then they might think, right, so it'll be one more remainder. That's what we're hoping for. So they would say 324 remainder 4.
You can carry on like that and discuss what would the question be if it was remainder 5, if it was remainder 6. You could push them a bit further and say, what would the next positive whole number be that when you divide by 14, there'd be no remainder? Are they able to count on and work that out? You could also ask them, can you give me another question that when dividing by 14, that would also give a remainder of 3? So it really gets them thinking more deeply. And once you've had a really good chat about that question and the questions that are sort of surround it, then my advice then would be to do another 4-digit number divided by 14, because they've already drawn up their chart, and actually it just helps really give them loads of opportunity to practice rather than starting all over again. So give them a separate question, but still dividing by 14. They may need to add to this, but they can definitely use it again.
Here is a summary of the main teaching points. When looking at regrouping in short division with your child at home, especially if you're just introducing it for the first time, only regroup in one column. Start slowly and build from there, moving to regrouping in 2 columns, 3 columns, and then moving on to short division with a remainder. By taking it slowly, encouraging them to be active mathematicians and taking charge of their learning, it really will make a difference. To help with that, you might like to use some manipulatives and some images, but be mindful that these have their place, but as soon as the numbers start to get too big, it tends to get a bit too overcomplicated. But see what your child needs, see how they react to using them, see if it benefits them, and go from there. Once you get to questions where you're dividing by a 4-digit number by a 2-digit number, then you need to be thinking about another approach. And I really recommend using the partitioning model rather than solely relying on a short multiplication. It really gets your child to practice their multiples of 10 and also their times tables.